Hi everyone. I think we're going to start now. So, hi everyone. My name is Arthur Waknin. I'm a postdoctoral researcher at McGill University in Milan. I'm also a co-team member at Climate Change AI, and I'm leading the webinar team. Welcome everyone to our CCAI webinar series. Today we will have a panel discussion on forest monitoring for carbon stock estimation. For those who are attending for the first event from CCAI, we're an initiative that fosters impactful work at the intersection of climate change and machine learning by providing educational and CCAI conducts various initiatives to disseminate knowledge at the intersection of climate change and AI. We offer digital resources and coordinate a range of events, including summer school, conferences, workshops, webinars, and meetups. We provide grants to support the establishment of programs. We are actively engaged in policy conferences to foster discussions. Additionally, we bring together a vibrant community that stays informed through regular updates via our newsletter. For more details, you can visit our website at climatechange.ai. By joining our community platform, you will gain access to valuable information from CCAI and have the opportunity to connect with people interested in various fields of application. Our blog posts are available to everyone and cover a wide range of topics, including research application and presentation from our team. If you're interested in what we do, you can follow us on Twitter or register through our newsletter, where you will have various updates about conferences, funding opportunities, recent projects and articles, and for sure job opportunities as well. So to make this webinar interactive, please connect to the associated Slido link that will be in the comments of the Zoom. In the link is also available on the YouTube live stream description and also in the reminder email that you received recently. You will be able to ask your question on this platform and upvote to your favorite ones. And the question with the higher number of upvotes will be more likely to be asked. So this webinar will be organized as follows. Each speaker will have around 5 minutes to present his or her work. We'll then have a 25 to 30 minutes panel discussion, which will be followed by a 15 to 10 minutes Q&A session at the end. So please add your question to the Slido, and we'll try to do our best to process them as we go. So without further ado, let's introduce our speakers. First, Elias Ayre is a forest remote sensing scientist by training, who's been in the carbon industry for the last 5 years. He is currently a co-founder and chief science officer at a carbon rating agency called Greenhoster. Greenhoster's global goal is to evaluate the world's nature-based carbon project and determine if they're fulfilling their carbon and community benefits. Elias is also creates educational videos about carbon industry in this spare time, which are designed to help carbon purchasers to make informed decisions. Then Marta Morrissey, she's a senior machine learning engineer at Pachama. Prior to Pachama, Marta worked at Development Seed and Maxar. Marta has an undergraduate degree from UC Berkeley in geography and a master's degree in geography from the University of Colorado, Boulder. Outside of his work, Marta loves spending time outside cycling, running, and attempting to take her cat on walks. And Leland Worden, at the end, thank you, is a restoration ecologist who focuses on developing tools to conserve and restore degraded forests. Leland spans ecosystem from temperate forests of the northeastern United States to the tropical wet and dry forests of Costa Rica, Hawaii, and Mexico. Leland is currently a restoration ecologist at the Crowther Lab at UTH Zurich, where he is developing a global network of forest restoration experiments. So thank you everyone for being here today. And Elias, I leave you the floor to present yourself.
Sure. Yeah, thanks so much for having me. Yeah, my name's Elias. My background is initially in forest science and remote sensing. So that's where I did a lot of my academic work, mapping out forests, um, primarily using AI. And currently, yeah, like you said, I'm a co-founder at a carbon ratings agency called Renoster. And Renoster's whole goal in life is basically to evaluate carbon projects to a very high standard and make sure the whole world knows which projects are really good and which ones are really bad, so that we can improve the whole space and hopefully make carbon credits better. You want to hit the next slide? So I really wish that my company didn't have to exist. Nobody like dreams of going into, and being a babysitter for a carbon market or something as a child. But the fact is that Renoster exists because there's a lot of concerns around carbon credits today. There are greenwashing concerns for people buying the credits, so they get very worried that they may be labeled as greenwashing, even though they're trying to do the right thing about their emissions. There are scientific concerns. Some of these carbon credits are maybe not up to scientific snuff. My company is all about trying to evaluate the scientific rigor of these projects, and we actually employ more than 60% of our staff as scientists. Um, if you're trying to buy credits, you often don't have weeks and weeks to review these projects and figure out if they're good or bad. So we offer a lot of that diligence service, as a service. And then finally, there's a lack of trust in this space. So there's a lot of conflicts of interest that are in the voluntary carbon markets. And what we're trying to do is act as a real third party to say what's going on. You want to hit the next slide? There we go. Thanks. Yeah, so the reason that we have to exist is that there's just no denying that the majority of nature-based carbon projects overestimate their impact, both in terms of climate impact and co-benefits. Um, I wish this weren't the case. There's a large body of academic literature at this point that kind of illustrates that a good chunk of the credits on the market are not doing what they're supposed to. Our own findings indicate that something like 75% of the carbon projects on the market today are overissued credits, and that ratio is about the same in terms of the amount of credits that are good versus bad. So this is because the space is so complex and a little self-contradictory. This is why third parties like my company are sometimes needed to say what's going on. I want to hit the next slide. Yeah. So how does a customer actually choose how to buy carbon credits, like how to handle their emissions? It's a fiercely complicated space. Let's go on right to the next slide. I whip them out here. Yeah, I mean, the problem is that there's a huge number of different standards and bodies and stamps that people put on these carbon credits, and it's very difficult for kind of the outside customer to understand which ones of these are to be taken seriously and which ones aren't, and ultimately which ones are going to lead you down the right path. So there's a lot of different sources that customers can turn to. There are the people creating the credits, like Vera. There's the UN sustainability goals, which are always something to aim for, but there's not much regulation around what your stamps. There's Article 6 eligibility. There's just independent reporters who just do their research on these projects and sometimes come to horrible conclusions, but then other times come to good conclusions. And then there's these other standards out there like CCB standards, but all of it is very difficult to navigate, and it's difficult to understand which of these standards is really pointing you towards quality. So you want to hit the next slide here. So what Renoster offers are deeply rigorous reviews. We usually do something like 25-page reports to say whether or not what's going on inside these projects is both good for the environment and good for human beings. And so we're offering like a level of rigor that we think is fairly unparalleled in the market to really get to the bottom of these very complicated projects. You want to hit to the next one? Yeah, so there's a lot of questions to be asked when you approach a carbon project, and typically we try to quantify 7 of them. I'll go through them real quick here. One of the first ones is the project justified at all? Are they protecting trees that needed to be protected? Are they planting trees that were otherwise going to be planted? The next question is, what would have happened if the project didn't exist? So would the trees have been cut down, or would they maybe not have been cut down? The third question is, how much carbon is there? Are we actually measuring that properly? The fourth question is, by preserving these trees, are bad guys just going next door? We don't want a situation where we preserve like one forest and another forest just gets cut down because of that. And then the fifth one is, how long are these trees really going to be around? Or how long is the carbon project itself going to be around? You want to hit the next one. So the last two really important elements are, what are the community benefits to these projects? So are the people on the ground actually earning money from this project? Are they earning an equitable share? Because they are the ones who are giving up a natural resource in order to participate in this project. And then finally, what are the ecological co-benefits of this project? So what services does the forest offer humanity? I mean, is there water filtration? Is there biodiversity? What's being done here? So next slide. So what we offer to our customers are really in-depth portfolio analyses of what their projects, what the previous credits that they've bought are actually worth. What our findings are on these projects and where they may have gone right and where they may have gone wrong. And ultimately, what we want to do is point our customers towards buying really great carbon credits, and then finally incentivize people to only create really great carbon credits. Next slide. And the way that we do this is as a really intuitive ratings scale. What we're trying to do is use satellite imagery and artificial intelligence to come up with our own set of numbers for carbon projects. This is how much carbon there is. This is the baseline, all of these numbers, and just compare them to the projects. And so our score is really just a ratio between what our finding is and what their finding is. And if it's above a 1, then the project is great. It's getting too many credits. Not too many. Sorry, it's getting maybe not enough credits. And if it's below a 1, then the project is dicey and it's maybe getting too many credits. Next slide. Yeah, so I think there's a number of things that we try to do differently. We try to show all of our work very publicly. We try to do these really in-depth analyses. All of our reviews are very independent, and all of the projects that we review to a high depth end up getting made public after about 6 months. So just yesterday, we posted a new project publicly so that everyone can know which project is good and bad. So that's the wrap up of Renoster. And yeah.
Thank you, Elias. Martha, I'll leave you the floor then.
Hi, thank you so much. My name is Martha Morsi. Again, I'm a machine learning engineer at Pachama, and I'm super excited to be part of this panel today. I think we all know that forests are important, but some fun forest facts before we dive in. Forests are an essential part of the climate change solution. We need trees and we need forests to start mitigating the impact of climate change. They'll account for about a third. Nature-based solutions will account for a third of the mitigation efforts needed within the next decade. Forests are critically important for biodiversity. They're home to 80% of the world's terrestrial biodiversity, and they're also critically important to people as well. 25% of the world's population relies on forests for their primary income. Next slide. So carbon markets are obviously a big part of nature-based solutions. But as Elias talked about, as I'm sure most people are aware, there's been a lot of press coverage recently. The existing carbon market lacks trust, transparency, and accountability. But we do still need trees, and there still are legitimately good carbon projects out there and good carbon projects that can be developed. Next slide. So how can we do that? Over the past few years, there have been incredible advances in technology with the launch of so many different satellites that allow us to observe Earth. Next slide. So traditionally, forest carbon credit projects have been understood through very manual methods. People are going into the field and surveying trees and measuring them, but we can combine these technologies and bring increased transparency to the market. Next slide. Yeah, so we want to bring, Pachama's aiming to help protect and restore nature. We can click through all of these, and add transparency to ensure that people are buying high quality carbon credits, and that we're also helping initialize high quality new forest carbon projects in a way that's transparent and scalable, because we need to protect existing forests that are standing today as well as start new carbon projects. I'm excited to dive into more technical details about baselines, uncertainty quantification, and biomass mapping during the panel question section. Thank you.
Thank you very much. Even I leave to the floor then.
Thanks. Super excited to be here and just kind of learn more about the AI space and this kind of work. And I'm Leland. I'm a restoration ecologist at ETH Zurich. And over the past couple of years, I've been working on scaling our understanding of restoration outcomes through global experiments and also synthesis projects, primarily working with Rebecca Cole, who's also a restoration ecologist with us based in Costa Rica. Next slide. So we're really working currently in this group on building the next generation of restoration science. And from our eyes, the kind of key questions that we're addressing, number one are, should we be doing natural versus assisted restoration? So should we essentially let ecosystems recover on their own, or when should we assist recovery? This is obviously very context specific, but we're doing experiments and trying to tease this apart. Second piece is we're looking at kind of holistic assessments of restoration projects. Obviously, Elias talked a bit about leakage and thinking about the negative impacts that restoration can have, but typically when people kind of look at restoration on the ground, they're really only thinking about the positive benefits. So we're trying to bring all this together so that we can create these really kind of holistic metrics of restoration outcomes. And then finally, instead of only working kind of on tropical or just on forest recovery, we're thinking about how to optimize recovery for different land use types. So this includes production systems such as agriculture, agroforestry, to try to kind of maximize biodiversity outcomes in all these different types of contexts. Go to the next slide. And we have three core approaches, one of which is a global experimental restoration network, which we call the Global Experiments Network, where we're essentially working with restoration practitioners on the ground to implement restoration experiments. We've started primarily in Latin America, but we'll be expanding to other parts of the world soon. The second part, we are basically kind of taking the pulse of the global restoration movement, and this takes part by essentially speaking to and surveying hundreds of restoration practitioners around the world to understand what their needs are, to really design research that is based primarily on the needs of these projects rather than kind of creating the questions ourselves. And then finally, we've been doing some really large-scale synthesis projects, kind of combing through tens of thousands of papers on restoration failures and successes to try to help people think more about monitoring their project outcomes. So we're just kind of taking this retrospective approach so that we can try to understand different ecosystem recovery rates. And I'm just going to give some examples from the restoration network part. Essentially, this is a project that we've been scaling out. We currently have 20 sites across Latin America. And we're essentially just looking at projects that are doing some form of assisted recovery, mostly tree planting because it's a common intervention in this area. And then we're working with them to just put in control plots. So typically when we look at assisted versus natural recovery, there's been a lot of studies that have shown that natural regeneration is really excellent in certain contexts, and others have shown that assisted recovery is necessary, but it's very rare that they happen at the same place. Go to the next slide. So what we're doing with primarily NGOs and some for-profit organizations is essentially helping them just to put in a control plot where they measure the recovery of carbon and biodiversity using really simple protocols side by side. So not shifting anything within their practices themselves, just leaving an empty area, maybe fencing it to remove unwanted grazers, and then actually just comparing recovery. So by kind of building this experimental network, we're going to be able to create much more robust estimates of what type of restoration we might use in a forest context. Next slide. And then in certain cases, we're doing paired experiments where we're manipulating different types of restoration approaches, such as adding adding microbiomes, so just soil samples from intact forests, adding waste of agricultural byproducts such as coffee, so that we can start to dial into some very specific restoration approaches that are used within different contexts. Next slide. So we've kind of started in Central America and South America, starting in 2022, and our end goal is to expand to different parts of the tropics, specifically working on forests. And we've spoken to about 300 restoration practitioners to get a sense of all of their kind of outcomes so far and establish these 20 experimental sites in less than 2 years. And we're kind of expanding now with a focus on looking at regenerative agriculture and agroforestry and different types of restoration interventions. And that's it.
Thank you very much for your presentation. That was really, really interesting. That's really cool. You have a lot of different backgrounds, a lot of different knowledge. So yeah, let's discuss now. I wanted to start the panel discussion with a question for you, Lilian. So you've discussed a bit of your background, and so you're in contact with actual practitioners for forest restoration. Like you presented a lot of your work. You've been in Costa Rica, for example, to work on restoration at large scale. I wanted to know what you think about the current practical potential of reforestation and afforestation project at large scale, and both in terms of biodiversity stabilization and carbon sequestration for climate change mitigation. So I know it's a really large question, but feel free to answer as you can.
Yes, great question. So in general, I think there's enormous potential, and I think a lot of the kind of community has settled on the fact, though, that we have to prioritize protecting existing forests first and also improve forest management before we even think about scaling restoration projects. So obviously, just keeping what we have in terms of biodiversity is super important. But obviously, we have to kind of get things moving. So there have been incredible large-scale forest landscape restoration projects that do lots of good, both in carbon mitigation and biodiversity stabilization. But the ones that typically kind of exist over long terms have buy-in from communities. So it's super important, obviously, to have communities involved in the planning process and make sure they benefit from projects. So we can't only think about the ecological side of things. Humans are super important. And as Martha mentioned, there's many analyses that essentially indicate that 30% of emission reductions can kind of be offset using natural climate solutions, particularly in forests. But we have to cut emissions on top of this. But generally, I do have a lot of, and this is why I work in the space, optimism that this can work. We just need to make sure that we're focused not only on carbon, but also biodiversity, because biodiversity kind of leads to increased carbon capture. And just think about the different types of restoration that we can use to make sure these outcomes happen.
Yeah, that's true. Yeah, completely right. And that's sometimes what we call co-benefits, like to like stabilize the biodiversity or increase the biodiversity while we have a reforestation project. But we should maybe talk to it as part of the project itself. And by the way, you mentioned also the fact that we should probably protect the forests as they are for the moment, and this is what we call maybe in the next question and so on, avoided forest conversion, or in a general manner, like avoiding to touch about this forest and keep it as it is. Yeah, thank you for that. So Elias, I wanted to ask you, so just to introduce the question. So we know, as you presented, and Martha presented a bit as well, so there is an increasing number of projects in the industry to protect or create a forest as natural partial solution to absorb carbon from the atmosphere. And some of these projects are generating carbon credits for diverse applications, such as I said, avoided forest conversion or forest management or reforestation, afforestation. Just for our audience, I just wanted to ask you, can you first explain us what is a carbon credit, and what is, like, in a few words, a link between the carbon market and this application, this industrial application?
Yeah, well, carbon credits are a really simple idea. We all need to reduce our emissions. We all have emissions if we're driving around to work and stuff. Companies have emissions when they create products. we're not all able to reduce our emissions down to zero right now. That's just not possible for anyone operating in the current world. And so if you still have emissions after you've done everything to reduce them, what you can do is you can buy carbon credits to kind of offset them. And the idea behind that is just that if you're putting a ton of carbon dioxide into the atmosphere by driving around, you can take a ton of carbon dioxide out of the atmosphere somewhere else. And at the end of the day, it should all balance out. And in a perfect world, if everybody were reducing their emissions and buying carbon credits for the rest, climate change would halt, right? We wouldn't have any more emissions into the atmosphere. We're a long way away from that world, though. Now, there are kind of two fundamental different types of carbon credits. There's avoided emissions, which are designed to prevent carbon from going into the atmosphere. And there's removals, which are designed to take carbon out of the atmosphere. So avoided emissions credits are based on this idea that if we can say for absolute certain that carbon was going to be emitted by some process, then we can stop it, and we can issue credits for stopping it. So examples of that include avoiding deforestation. So massive amounts of emissions are produced every year through tropical deforestation, and if we're able to support stopping that, we can prevent carbon from going into the atmosphere. But they also include things like cook stoves, renewable energy credits, methane capture. There's a lot of different ways in which we can prevent emissions from going into the atmosphere with some subsidies. Removals are, things like planting trees. So when a tree is planted and it grows, it takes carbon dioxide actively out of the atmosphere. Things like wood burial, biochar, direct air capture, these are all methods that actually remove carbon that's in the atmosphere now. People draw the difference between the two. If both systems worked, then the numbers should be the same. Next year there would be carbon in the atmosphere if there weren't today. So there shouldn't necessarily be a difference, but there is this philosophical difference there. And I think the other important point is that all of these project types are based around a baseline, which is basically the underlying assumption of what may have happened if the project didn't exist. So we can't issue credits for planting trees unless we know for certain that the trees wouldn't have been planted anyway. And we can't issue credits for avoiding cutting down trees unless we know for certain that those trees were going to get cut down. And these baseline scenarios, these kind of alternative null hypotheses, these are what we're kind of validating against when we say whether or not the credits are any good. And these are where a lot of the drama occurs in the carbon markets, because it is kind of a hypothetical alternative. So.
Yeah, thank you for this detailed question. So just just a comment, it's a really simple question, I would say. So we're talking here about reforestation or forest monitoring in general, but can we create carbon credits with other methods that could absorb carbon from the atmosphere, for example, or like reduce the emission?
Oh, they do all the time. Something like 70% of carbon credits are for trees, but there are many other types of carbon credits out there, including like gigantic machines that pull carbon out of the atmosphere, and including capturing methane from waste that we know is going to go into the atmosphere. So there are lots of different types of carbon credits, but my company does specialize in nature-based credits.
Okay. Thank you for the details. Yeah. So Martha, I wanted to ask you more details about Pachama. Just to introduce the topic, so a lot of startups are emerging in the market, and they're trying to combine forest monitoring and carbon stock estimation to generate carbon credits for different kind of application. Pachama is one of these company, which is well known in the field since it also had a really large fundraising in 2022. Can you tell us a bit more about Pachama and where is the current focus of your projects?
Yeah, thank you. So the current focus at Pachama is kind of twofold. We want to enable companies to make an investment in forest-based carbon credits that they feel really confident in. So we verify existing projects, and then we feel confident that those projects have an actual climate benefit as well as an actual benefit to the communities where they're situated in. And some of those existing projects are avoided unplanned deforestation, where there's like mature forest that hasn't been cut down. There's also existing projects that are reforestation projects. So new trees have been planted. And then we provide information and give buyers more transparency about them. And we also facilitate the sale of those credits. Another avenue Pachama is focusing on is called Pachama Originals. We're focused first in parts of Brazil, Mexico, and the US, and starting new carbon projects from the ground up, which is really exciting. So on land that used to be crop or pasture, we help facilitate and build tools so project developers can make projects with high quality credits that meet the standards of registry bodies like VERA. VERA has just released a new methodology for those ARR projects that's sometimes complex. So we're helping project developers navigate through that. And we're also providing additional standards on top to try to ensure it's a really high quality credit. And it's going to last for the long term.
Okay, well, thank you for these details. That's pretty clear. And thank you for all of you for all of this large introduction, let's say. I wanted to go more in details about like the tools that you are all using in this in your work. So so many projects in the industry have been started to generate carbon credits thanks to their positive carbon impact, as we discussed a bit in your presentation and in this discussion. So it can be to preserve, to improve, or to restore forests. So Elias, in your work, you're trying to bring transparency on this project at Renoster. So you talk to us about how to measure the positive impact of this project. So it can be by, for example, verifying that these forests are actually not cut and they should have not been cut, for example, to generate the actual credit. And can you tell us a bit more about like where are you bringing the transparency at Renoster on this project?
Yeah. So at Renoster, our goal is to basically use remote sensing and artificial intelligence and some regular old detective work too, to basically test all of the assumptions of carbon projects. So there's a lot of assumptions that go into carbon credits. There's, were the trees really at risk? To what extent were they really at risk? Did the neighboring trees get cut down because of it? Are they measuring their carbon correctly? And so we try to take on all of those questions ourselves. And it typically takes something like a month to do these reports. And we try to put together our own reports that come up with our own answers. And we're doing so in kind of a blind fashion. We're coming up with our own answers, and then what we're doing is comparing them to the projects and seeing where there may be any differences. And so some of the times we find that the projects are overly conservative. We know of a number of projects that maybe should be receiving more credits than they actually are because they were very safe and cautious with their numbers. And then some of the times we see projects that are under conservative and getting too many credits. So what we're really trying to do is share all of what we think constitutes a good carbon project and kind of walk people through exactly how that works. I do want to be. Let me just say that we have a lot of grim statistics in the carbon industry that like 75% of carbon offsets aren't doing what they say and stuff. But what that implies is that 25% of carbon offsets are doing what they say. And the notion of carbon offsets are perfectly fine. There's nothing wrong with putting a ton of CO2 in the atmosphere and taking it out somewhere else. And in fact, if 25% of offsets are great, then that means that there's more than 250 million tons of carbon that's been removed by great projects. We see projects that are like directly paying hundreds of thousands of small landowners to plant trees. We see projects that are reforesting areas the size of small countries. We see projects that are, again, the size of like small countries or like US counties that are stopping deforestation dead in their tracks. So it absolutely can work. I think the whole space would be better off if we were a bit more transparent about how these projects did work. And so, if I were going to improve the space, the first thing I would do is completely make everybody transparent and share the locations, share the budgets, share the maps, and share the accounting behind all of these credits. And I think that would really bring everything up to the same standard as the 25% I was talking about.
Mhm. So just to make it a bit more clear for me, it's basically you're trying to assess like the credits by comparing what you can measure with remote sensing, for example, data compared to a baseline that you also build.
Yeah, absolutely. So we create our own baseline. We have our own carbon stock estimates. We have our own leakage estimates. We basically have our own set of algorithms for creating these projects internally using remote sensing. And we always report like how the algorithm works and what the uncertainties are and stuff, in the project reports. And the goal is just to do a one-to-one comparison and see where there may be differences. And so the goal is to make it very simple for the end buyer, using Renoster's method. This is how many credits the project should have gotten. This is how much it actually got. So.
Okay, thank you. Yeah, so I think it's also important like to go back to the field and understand how difficult it is to plant trees and manage a forest and estimate, for example, like the above ground biomass, which is also the carbon stock estimation. So Lilian, I wanted to ask you as a restoration ecologist, what is the process and which tools do you use to actually restore a forest?
Yeah, so generally the process starts, if a project is set up well, with kind of doing a community-based stock taking exercise and actually working with stakeholders within the community to set initial goals. And then that goal setting process is incredibly important because it dictates how the restoration itself is implemented. So obviously, there will be certain things that are prioritized over others, but it's good to have multiple goals. So, for example, both biodiversity and carbon sequestration at the same time, and then set rigorous kind of things in place for how you're actually going to do the monitoring and pick indicators ahead of time. So obviously, it's good to bring in remote sensing data products, but actually getting ground source data is really important as well too. So, for example, if we're thinking about carbon sequestration on the ground, there are great protocols for measuring tree growth and kind of getting a good idea of how much carbon is getting captured within the system by just measuring the stems of trees, their heights, and the species. This isn't a trivial thing to do, but at least there's like a framework in general for it. And a lot of projects do have the capacity to do this, even though protocols kind of differ region to region. And then just in general, we think about how we can actually scale this work. And usually that means that we think about using some type of remote sensing. But I'm just kind of a general advocate for making sure that we collect rigorous ground-based data, at least within some plots that are randomly distributed across projects on the ground, so that we can get a sense of actually what's going on, because satellite remote sensing, like we're talking about, is getting so much better and much more precise, but there's still a lot of uncertainty associated with it. And I think global estimates are that just on average, there's about 10% of uncertainty in carbon estimates around the world. And the more data we have on the ground, the better those models will get. And then eventually we may be able to kind of cut out that on the ground measurement. But I think it should always kind of be there as a check. So long story short, setting goals and then actually figuring out how to measure them is complicated. But as long as you kind of use these existing frameworks, then this is kind of how we kind of cut through the noise for designing projects in different contexts.
Yeah, that's true. And I mean, that's the work of forest ecologists for a long time, I would say. And so I'm working with a few forest ecologists here in Montreal and Quebec. And I've learned that actually measuring this above ground biomass or the carbon stock of a tree can take several minutes, even more. So if you want to scale to an entire forest, it's kind of complicated. You cannot measure like all the trees of a forest for a project or just to measure like the carbon in a forest. So can you maybe tell us a bit more how can you scale actually to a forest if we think only on the manual estimation?
Yeah, I think so. Obviously, if you're working in a really large scale project, the way that this has been approached is through kind of stratified random sampling. So that actually means essentially you say, okay, we have 10 different general contexts within the area we're working. Maybe it's different levels of degradation, different soil types, different species mixes. And then we place random sampling plots within those different contexts and then get a good average for recovery rates within each context. And there are really nice statistical approaches that we can use through power analysis to determine how many plots we should actually lay out. And there's a really, really nice paper that I reviewed pretty recently that was basically using the Brazilian Atlantic forest for this large-scale restoration that's kind of happened over the past couple decades. And they use these massive data sets to determine rules of thumb for the percentage of area that you could actually measure for different types of indicators. And the general idea is that you have to do basically 2 to 4% of your area in terms of sampling, but that changes as you go up to really large scale projects where you can't do that. But I think we can, with the massive data that we have from on the ground projects, start to estimate how much area within specific types of contexts, kind of stratified based on type of area that you're working with, determine just generally how much area should be measured so that you're not over or under measuring on the ground. But I am confident that remote sensing is very helpful in this context too, in terms of scaling, as long as we make sure that we can decrease the uncertainty as much as we can through gathering more ground-based measurements.
Yeah. I understand. Yeah, it's really interesting. I'm not aware about this paper, but I guess it's like having bringing like the theory of statistics to have correct estimates of the population, like the diversity, the density of the trees you can have. So yeah, for sure, that's a good transition because we for sure need to use remote sensing data for that and to scale at least. So Martha, I wanted to ask you, since you're working a lot with remote sensing and potentially at large scale, sorry. So which tool do you use to quantify carbon losses or carbon gains of forests, in terms of data, like it can be which kind of remote sensing data you're using, and in models as well, which kind of models are you using? And as we discussed before, I guess it's also related to the baselines that you define, because it looks like we always refer to a baseline, right?
Yes, I feel like that's 5 questions like wrapped into one. We'll kind of break it down. In general, Pachama uses a lot of open source satellite imagery, like Landsat, which is 30-meter resolution, Sentinel, which is 10-meter resolution, and we use open source products that are derived from those, like Global Forest Watch. An interesting challenge is that those are not super high resolution compared to commercial satellite imagery options. And when you're trying to measure the growth of very young trees, that provides some challenges. But then to really understand baselines, you have to be able to go back in time and understand what the land was doing like 10 years previously. And then there's obviously like lower bounds on precision. Like how well can you estimate what X% of pixels that are growing a height of 1 meter in a 100-hectare project? That's obviously quite challenging. But then when you bring in data like LiDAR and drones, that gives you more data, but that obviously becomes less scalable. So it's kind of a balance. So in terms of like models that are in research phase, those are very like regional and project specific right now. But then when we're working with baselines for existing AUD projects, for example, we're able to use global data sets and open source data. So it becomes easier to work with those at a global scale. Do we want to talk more about baselines right now?
Well, we can discuss about a lot
Okay.
of things. Yeah, no, I would like to know, like, do you have like any so I guess you're using like machine learning and statistical methods maybe to estimate that. And have you noticed like methodologies or models that works better than others, for example?
It depends on like what question we're asking. The methods are quite different. At a high level, we're doing KNN matching to quantify baselines, and that does seem to be working quite well. It aligns with like published papers that are are like already established, and you don't actually need that large a feature set to get a good signal on a baseline. And what we do with baselines is you look at areas that are outside the project, but similar to the project, and then you do KNN matching to get a set of control pixels. And those represent what would happen if the carbon project didn't exist. And this is exciting because you have these like placebo projects that are fake projects, but they're not actually protected. So you can go back and understand the deforestation there as well as their control pixels. And that gives you a sense of uncertainty that you can apply to the original project area and quantify uncertainty there. We have some slides if you want to go to them.
Well, I just wanted to
Okay.
to like summarize if I understand well. So in a really general manner, it's like for example, you're comparing like a region where you have a protected forest and see like if the credit to ensure that the credits have been well generated, you like compare to the region which are around and see like the trends in the pixels time series basically to see if like the forest has been like correctly protected, and if like yeah, I guess it's most of it.
Yeah, exactly. And this is exciting because currently today there's no rules. Project developers can just issue a baseline and there's no uncertainty associated with it. And it's kind of taken as fact. I think every few years they do have the opportunity to update their baseline. But as we've seen, there's political events like conflicts and changes in a country's political leadership that can have a huge impact on deforestation rates and what's happening in the ground. And when you have methods like a dynamic baseline, those are able to be captured.
Okay, thank you. Thank you very much for that. And I think yeah, like in this project, like uncertainty is really important to quantify for sure. So Leland, I wanted to ask you like about the like planting trees and restoration project. So many current projects involve planting forest as monoculture actually, which does nothing to restore in biodiversity and can maybe also increase the risk of disease spreading, for example. So as you said, you worked also on a multi-species restoration projects. And I think it's necessary to take that into account when we try to estimate the carbon stock of an entire forest, for example. Like, do you know if there is like a really important difference in the carbon stock that different species can absorb? Is it really significant? And because if we try to scale that on an entire forest, maybe we will need to really distinguish all the species that are in the forest.
Yeah, so at the species level, there's an enormous range in the amount of potential that a certain tree can have in terms of carbon capture, and that has to do with the architecture of the tree, its wood density, just generally how much carbon it can store. So it's important to get a handle on this to actually make those estimates, but we also can just use some general rules of thumb and understanding that just multi-species plantations have been shown in multiple experiments and actually far more than multiple, in many contexts, to capture much more carbon than monocultures. So I think just generally, yes, species mix is important, but higher diversity mixes lead to more carbon capture because all the different tree species kind of fill different niches and use resources in different ways than just a straight up monoculture that can basically just on average capture kind of half the amount of carbon. And there's really good examples of this in tree diversity experiments in China and elsewhere. So yeah, it's good to know what the species composition is in a really complex tropical forest. You can have hundreds of species per hectare. But in the end, if we do know the system pretty well, we can get an idea of kind of what the average is in terms of carbon capture and then scale that with remote sensing.
Okay, thank you. Yes, that's huge. I mean, I didn't know that number about the difference between monoculture and multiculture. That's something definitely to push. And from what I've understood, it's also better for the biodiversity restoration to have a multi-species culture, actually. Yeah, thank you. So actually, depending on the diversity on the species, we can have a lot of different estimation of carbon. So at a really and at a, let's say, different point of view. Elias, I wanted to ask you, so that since we can see that this estimation can integrate a lot of different uncertainties, which can come from a lot of different things. It can be from the data, it can be from the models, it can be from the forest itself. So like the actors in the carbon market related for sure on forest projects, do they provide like consistent and relevant uncertainties related to their estimations?
Yeah, I mean, I struggled with how to answer this question in less than an hour, but I think let me touch on a couple of points. And I think from a traditional field inventory perspective, people are pretty good at measuring trees in the field at this point. Leland already pointed this out. Traditionally, you go out there, you sample some number of trees, you measure their height and their diameter and their species, and you can basically estimate carbon fairly accurately at large scales. And your uncertainties can be worked out through basically frequentist statistics. So you can get a standard error and you can get a confidence interval, and then you can say how uncertain you actually are. In terms of the carbon markets, most protocols follow this approach. And there's a couple that don't. Vera is the glaring exception. It is still the Wild West on Vera's platforms about how you measure your carbon, and we see all kinds of stuff. But a lot of Vera projects still do measure their carbon and report their uncertainties in a professional way. Now, that's to the traditional field inventory techniques. But when we enter into the world of like AI and remote sensing, it gets a whole lot more dicey. A lot of people out there are creating like widespread maps. And the way that they're doing that is they're taking a set of training data where we measure the trees by hand, and training some sort of like deep learning model or something to estimate carbon across the whole landscape. And that comes with its own unique challenges in terms of uncertainty estimates that I don't think the field itself has really like settled on how to deal with. I'll highlight two. One of them is this idea of multiple levels of uncertainty. So when you're training a model off of a model, uncertainties add up. In many cases, we're training models off of models off of models, and even sometimes off of models. And it's very difficult to quantify the uncertainties at each stage and then get an end output that is reasonable. The other big problem that I see out there in the field for remote sensing is we're training models off of broad landscapes. So my models are maybe trained off of thousands of field plots taken over like the state of Washington where I live, right? But then we're applying that to a really focused area where there's a carbon project. And there's a problem called spatial correlation that exists in that situation where if my model is at the whole landscape really pretty good, like within 5% error, if I zoom into my backyard and there's only one type of tree in which my uncertainties are much higher, then my uncertainties for that particular area are going to be really dicey. And so there's a lot of really fierce statistical problems that exist out there that still have to be solved. But there are like really cutting edge, academics that are working through this right now. So.
Yeah, thank you for the answer. For sure, it's still an open question, I would say, and moreover for deep learning application and machine learning in general. So yeah, we will. So we're a bit late, so we're going to jump for the Q&A session. We had a bunch of questions online. Yeah, for the audience, feel free to ask your question on the Slido link. And I think this first question is related to what we were discussing. So the question is, do you use machine learning to estimate forest growth and biomass density at location where ground truth data may be sparse? So how do you validate these models? Who wants to answer on this?
Sure. I don't want to monopolize this. Yeah, so our models are trained off of field plots that are scattered across the world in uneven distributions. And so we don't have any field plots in Papua New Guinea, but we still have to sometimes make statements about that. We have a complex decision tree hierarchy for how we actually make statements about carbon stocks. well, I guess at the base of it, if you don't have many plots to train your model's going to be less certain, and you still just have to roll with it. But what we also do is we have a decision tree that basically says, should we use the project's own estimate? If not, should we use an estimate that's created using a broader data set from like globally? If we do have more regional, better data, should we use that? And so our goal at every point along the stage is to get the best estimate that we can and to be fully transparent about what we can and can't do. And we can't map carbon over a vast majority of the world's forests very accurately right now. Carbon from space is very difficult if you're talking about little areas like carbon projects. We should all just be honest about that.
That's true, yeah. Martha, maybe you can, do you have any feedback from what you do at Pachama? Actually, which kind of ground truth do you use to estimate carbon stock?
Yeah, we also use field plots, and we're modeling in really localized areas, and we're also definitely taking into account spatial autocorrelation. We've seen a lot of issues when you try to work with a global model and apply it at the project level. Like uncertainty is better, and we feel more confident when we just have these more bespoke local models for the project level.
Yeah, sure. Thank you. So our next question is I think for you, Elias, because it's related to Renoster. The person asked, I would love to hear more about the specific AI approaches that Renoster is using, and what are the carbon calculation problems that are best suited for AI?
Carbon projects have so many different elements to them. So we have like several different models, and let me separate, I guess, three different interesting models. The first is the baseline. So what would have happened if not for the project? And the approach that we use is similar to Martha's in that we use like k-nearest neighbor matching to identify areas outside the project that are similar to areas inside the project and just see what happens to them over time. The reason that we go for that, it's very intuitive. And it's based on real observations. And so there's a real power to having explainability in a baseline model, because people really want to know, like, where did you actually get these numbers? And so we can actually point to forests that were deforested or forests that remain intact and say that's where we got the numbers from. We have to make a lot of maps. And so we have to make maps of carbon stock and tree cover and plantation coverage. And usually when we're making these maps, we're using like convolutional neural networks of different like types and varieties. Sometimes we use random forest if we're doing it quick for a specific project, but most of the time, like, we have global models that we have convolutional neural networks for maps, in which we're basically trying to aggregate global training data sets and create these models. One of the other elements that we're currently working on but isn't live is a decision model. And so what we're trying to do there is figure out, using a bunch of variables like socioeconomic variables and parcel data and accessibility, just a true false, like, was this forest at risk? And so the idea is maybe we can have a really simple model, not simple, but like maybe we can have a simple output that says like justified, not justified, but that's still in the works. And so right now human beings are still kind of eyeballing it and making the final call. So yeah, the answer is it depends on the model that we're talking about.
Thank you for these details. Yeah, we had another question. I think maybe Dylan, you can be able to answer that. Like the person asking, the understory growth is important for biodiversity. So understory meaning below canopy layer. Is it a challenging piece to account for?
Yeah, I mean, this is one thing that we lack right now, is that current remote sensing techniques, we usually just see the forest canopy and not what's happening below it. So for biodiversity, this can be a big limitation, but there's also been pretty incredible kind of advances in hyperspectral remote sensing that's helping us to sense biodiversity, at least in forest canopies. And I mean, it's still not getting us into that below canopy measurement, but it, in general, obviously the dominant species are the ones that you observe in the canopy, so at least you get a sense of that. And then again, you do need to do field sampling still at this point to get a sense of biodiversity below that.
Mm-hmm. Yeah, I understand. Well, okay. Thank you very much for this all these answers, and thank you everyone for attending to this panel discussion. So we're on time, and I think we will end here. So I hope it was informative for everyone. Our next webinar will be scheduled in February, and it will be about machine learning application for agriculture. In the meantime, remember that CCAI is holding a workshop at NeurIPS next week. And by the way, the live stream will be free and available to anybody who is interested, and it will be available on our website. So thank you, everyone, and thank you for the speakers for taking time to discuss with us today.
Thanks.
Thank you.